Today we're going to look at a one sample t-test for a mean, and the method we're going to use is the traditional method. So let's go ahead and get started. A person read that the average number of hours an adult sleeps from Friday night to Saturday morning is 7.2. The researcher feels that the college students do not sleep 7.2 hours. So we already have the information that we need to write our hypotheses. And when we do hypothesis testing, that is our first step. So let's go ahead and write our null and alternative hypotheses. Our null hypothesis is what we're going to assume to be true. So the null hypothesis is that the average number of hours is 7.2. The notation that we use for population average is mu. So mu is equal to 7.2. 7.2. Let's change that so it looks like a decimal. The next sentence says that a researcher feels that college students do not sleep 7.2 on average. So then that gives us our alternative. Our mu naught is that the average is not equal to 7.2. The average could be greater than 7.2 or less than 7.2. So that tells us that we have a two-tail test. If we keep reading, it says the researcher randomly selected 15 students, so that tells us our sample size, and found that on average they sleep 8.3. So if you take those 15 students and you find their average, that's what we call X bar. That's our sample average. The standard deviation of the sample is 1.2 hours. So our sample standard deviation is Sx. At an alpha equals 0.05, which is again our probability of making a type 1 error, is there evidence to say that college students do not sleep 7.2 hours on average? Okay. So nowhere in that are we given population standard deviation. And we're also given a really small sample. It's less than 30. So since we do not have the population standard deviation, we know what distribution we're going to use. We're going to use the t distribution. So our step 1 was to write the hypotheses. Step 2 is to find our critical values. So when we use the traditional method, step 2 is to find our critical values. To find our critical values, we have to know what distribution we're using the t distribution because we are not given the population standard deviation. So to remind ourselves, the t distribution looks a lot like the normal distribution. It just has fatter tails. So it looks something like this. We have a two-tail test, so we know that we need to shade in some area on this tail and shade in some area on this tail. We're looking for the value right here that separates the critical region from the non-critical region, or the rejection region from the do not reject region. Since alpha is given to us as 0.05, and we have a two-tail test, then half of alpha goes in here, and the other half of alpha goes in here. The t distribution is symmetric with respect to the mean, which is going to be right here. Now, to find these two values, our two critical values, we can use our calculator. We can use inverse t, because we have the t distribution. And the input values are the area. So from negative infinity all the way up to our first critical value, the area is 0.025. And then our degrees of freedom, which is going to be 15 minus 1, our sample size minus 1. When I put that into my calculator, I got 2.145. I got negative 2.145. So this critical value is negative 2.145. And this critical value is positive 2.145. Okay. Now that I have my critical values, I can find my test statistic and see if my test statistic falls in the shaded region, which is the rejection region, or the non-shaded region, which is the do not reject region. So my next step is to find my test statistic. And then we have a formula for the test statistic. We take x bar minus mu all over s divided by the square root of n. X bar was given to us. That was 8.3. Mu we get from our hypotheses, which was 7.2. S we got from that sample, which was 1.2. 1.2. Divided by the square root of n. N is our sample size, which is 15. When I put this into my calculator, I got approximately 3.55. So now what we need to do is say, does this test statistic fall in the do not rejection region or either one of the rejection regions? 3.55 on a number line would be somewhere about, maybe way over here actually, 3.55. That's definitely in the shaded region, which is our rejection region. So that tells us that we can make a decision. Our decision is that we are going to reject H naught. Well, since we are rejecting H naught, we have to figure out what that actually means. So I'm going to come back up to my hypotheses. If I reject H naught, that means I do have evidence to support the alternative. So at the alpha equals 0.05 level, we have evidence to support that the average number of hours that college students sleep is not 7.2. So we have evidence to support this claim now. Let's go ahead and write the summary. So at alpha equals 0.05 level, we do have enough evidence to support the claim that college students do not sleep 7.2 hours on average from Friday night to Saturday morning. All right, this is the level of work I would expect to see on your midterm or your final exam. Feel free to email me if you have questions.